the average value function. F average is equal to 1 over the area of R times the double integral of R, f x y dA. Now, this looks a little complicated, but the interpretation is actually fairly simple. And it says, okay, and we're going to see the interpretation by looking at example 1 again, snowfall. I don't know about you guys, but if I tuned into the news right now and it said the average snowfall was, can't keep track of my answers to save my life. The average snowfall was 22 miles cubed. That right there is the look I'd have. Okay, what? 21 miles cubed of snow in my area? Is that a lot? Is that a little? I don't know what that means. What I want to know is what? The average snowfall. So the concept here is shockingly easy. You want to know the average snowfall? You look at how much snowfalls fell divided by the area it fell over. So, for example, from answer 1, we know that about 21.9 cubic miles of snow fell. Right? That was in fact our double integral. So our double integral was 21.9 cubic miles of snow. What was the area of that region we were looking at? The total area of that region,
388 times 276.
was 276 miles by 388 miles. Again, pull out the handy dandy calculator, and what you're going to get is this weird answer, 0.0002045. What's the unit on that going to be? Miles. Now, because that means nothing to anyone, no one would say it snowed this many miles. About 13 inches. That's still a lot, right? But at least I know that's a lot. Right? I don't have any basis for 0.002045 miles of snow. Let me make sure I plug that in. 2002045. Okay, thanks. So about 13 inches of snow. Not crazy, but kids probably aren't going to school that day. Let's look at example 2. So 1 over the area of the region, double integral of the region, f, x, y, a. In example 2, we found the double integral was equal to what? 48. What was the area of that region? 4. It was 0 to 2, x, 0 to 2, y. So it's a 2 by 2 rectangle. So it was 1 over 4. So it had area 12. Example 9. Ask us to go back and look at the average profit. Well, the total profit was, so the average profit is 0. Example 10 is the last one we're going to get today, so we're sadly not going to get to finish this entire packet, but it says find the average height of the surface in example 5. So we go back and we look at example 5, and we say, uh-oh. Example 5, were we looking at a rectangle? No. But, believe it or not, she's trying to help us out with this cross-section image. It's no longer the area of a rectangle, it's the area, not under the curve, closer, between. And how do you find the area between two curves?
Upper bound minus lower bound.
Upper bound minus lower bound. So now we just have to ask ourselves, which one of these is the upper bound, which one of these is the lower bound?
Well, once you switch the bounds, right? Will you get blind on now?
Well, it's hard to even orient top and bottom, right, when we're dealing in 3 dimensions. So we need to look at this slice and figure out which way it's going to go. So we're trying to find the area between x equals y squared and x equals y cubed. So perhaps the best way to do this is, you pull out your fancy calculator, and you say, well, if x is equal to y squared and x is equal to y cubed, again, these are the equations, square root of x equal y, and cube root of x equal y, and you just have to graph these. When you graph these, you'll find out which one's on top, which one's got the bigger values.
You can just throw in a 0.5 to kind of get an idea.
Yeah. And which one?
So, what's your square root?
Cube root is on top only because we're in what range? Right, they swap off. So maybe we should answer that question first. What are the 2 intersections for these 2 lines? 0 and 1. So while it's true that the cube root of, say, 7 is smaller than the square root of 7, between 0 and 1, fractions behave really oddly, right? This is where if you zoom all the way in, you'll see this weird thing happen. So this is actually going to need to be the cube root of x minus the square root of x dx. So I take the integral x to 1/3 becomes what? When you plug all this in, you'll get 1/12. So that means in this case, the f average for this function what was our answer from that? 0.09 will be 1/112 times 0.09, as he correctly said. This would be 12 times 0.09, which is equal to